Hello everyone, it's Mr. Wolfe here, and in this video I'm going to be walking through a level 2 problem, specifically scenario 1, where we have our two skaters skating down different sides of the hill. So two skaters of equal mass start from rest at the top of the same hill. They roll down the frictionless, so by the way, a few things I'm going to underline: equal mass. They roll down the frictionless surface to the ground on opposite sides of the hill. The skater on the right travels a greater distance, right, along the hill surface than the skater to the left. Makes sense. Shorter distance right here. All right. So the question is, well, how do their velocities of the two skaters compare at the bottom of the hill? Now, one question or one thing I kind of want to be aware of is keep in mind none of these things directly talk about height or velocity. They talk about energies. So I want to think about, okay, at the end of the day, what energy am I going to talk about? All right, that's going to answer my question about velocity. Well, that's going to be kinetic energy, right? All right. So this is a level 2 problem. So what I've done here is I've actually included what we would call our physics concepts. These are parts of the problem that lead us to draw our model the way we do. So some of you guys could possibly just start drawing your model and then explain it from there, but I kind of like to build our model with our explanation. So both skaters have the same mass and start at the same height. All right, well, if that's the case, all right, kind of thinking of our equation UG equals MGH, all right, same mass, same height, G is always the same. Well, that means that they have the same UG. All right, so let's draw that then. So I'm going to draw 4 blocks of UG beforehand for each one. All right, both skaters start at rest, so, well, if that's the case, there's no velocity, there's no K, right? So I'm just going to draw nothing here for K. So notice we're using this reasoning to construct our LOLs. You guys do the same thinking in your head when you've done your LOLs. The trick is just being able to effectively communicate it. So both skaters do not experience any friction. So if there's no friction, that means there's no work, which means I'm just not going to draw anything for my circle right here. All right. So then because both skaters experience no work, right, that means that both skaters, right, are going to have the same amount of energy at the end. If there was 4 in UG here, at the bottom of the hill, there's no height. And all that energy is going to be transferred into kinetic energy. Same thing over here, exact same scenario. So there are things that are different, right? They're going down different sides of the hill, different distances, right? But based on our concepts with energy, right, because both skaters experience no work and they started with the same energy, both skaters end with the same, not UG, K. All right. So now I know that they end with the same K, and that's going to help me with my concluding statement. Again, I want to talk about velocity at the end of the day, but in order to know about velocity, I had to know about my other variables right here. And I already know how their masses compare, right? I underlined that over here. Both skaters have equal masses. So what I'm going to do is I'm going to do skater to the left and skater to the right. They both have equal masses, so mass, I'm just going to box that in. And then they both have the same K. All right, so if that's the case, well, I'm going to box in K here too for my equation. I didn't have enough room for one half, and that's fine because I'm just kind of conceptually proportional reasoning with this. I don't necessarily have to do any math with it, so I just left out the 1/2. All right, well, if mass is constant, so mass is constant, so if kinetic energy, which I just also found out, all right, so if K, all right, is, and for you guys, you guys will have the option for the same, all right, then velocity, there's no other way around it. Velocity would also have to be the same as well, right? There's no other way. If velocity was different, one of these other variables would also have to change as well. So velocity also stays the same. All right. And if that's the case, then we've just answered our claim. All right. Both of them are going to have the same speed. So this is one of those interesting scenarios where I think a lot of us intuitively just think that this is a steeper hill, so this person's going to go just way, way faster, right? But if there's no work, right, even though they travel different distances, based on our concepts of energy, All right, they're going to have the same K, which means they're going to have the same velocity at the end of the hill.